Hello everybody! We are going to present you
Larsen effect.
We have all heard feedback before, but do you know what is it? It's the little unpleasant whistling sounds we have sometimes heard one day. Moreover, in scientific point of view, it's a periodic signal caused by acoustic feedback. In addition to, Larsen effect is a piercing or buzzing sound, often annoying or even harmful. More generally, it's a physical phenomenon, involuntary acoustic feedback. Nevertheless, contrary to popular belief, the Larsen effect isn't always a high-pitched sound. To sum up, this effect is produced when the amplified transmitter is too close of the receiver of an audio system. Now it's time to put the phenomenon Larsen effect in its historical context. First of all, the Larsen effect is described by the Danish physicist Søren Larsen in the early days of telephony in 1876. Let's go to display the mathematical concepts and tools inherent to the phenomenon. Larsen effect is a physical phenomenon itself. In fact, when we speak about Larsen phenomenon, we speak also about sound intensity, frequency, and sinusoidal signals. Sound intensity is the power transported by sound waves per unit area. I equal P divided S, with P the power in watts and C the area in square meter. The frequency is the number of times that a phenomenon repeats itself during a second. F equal 1 divided T, with T the period in seconds. Moreover, humans here can hear sounds between 20 Hz to 20,000 Hz. Sinusoidal signals is characterized by its amplitude and its frequency. Its mathematical expression is S equal Sm cos omega cross T plus phi, with Sm is amplitude in meter, omega is a simple in radian per second, and its physical expression is omega equal 2 cross p divided t, or omega equal 2p cross f, because f equal 1 divided t. Then the last quantity is phi. It's a phase shifts in radian. These are inherent phenomena. Finally, the most important is the explication of this phenomenon. Let's go! But how to explain his whistling? We assume a situation with a micro and an amplifier. The microphone only picks up the voice or the sound of an instrument. However, the microphone can pick up environmental sounds, such as those from a speaker. Let's imagine a sound issues in the microphone. This one comes out amplified from the speaker, but if the micro is directed at the speaker, the sound is picked up again by the microphone. Therefore, this will cause a loop as long as the microphone is directed towards the speaker. Consequently, this is what causes feedback. It can be high or low, and which makes that unpleasant is the frequency. A high frequency will give a high sound, and a low frequency will give a low sound. That's why, like we had said a little bit before, the feedback is a high or low sound that depends on the frequency. That's it. To end on sharp note, open your ears and listen to this beautiful feedback.